In section 6.2, we're going to look at the graphs of exponential functions. And so recall that exponential functions are of the form f of x equals a times b to the x, where b is greater than 0, but b can't equal 1. The point 0, a, is the y-intercept, and b is the growth or decay factor. When b is greater than 1, the function is going to be increasing. For example, f of x equals 2 to the x can be rewritten as f of x equals 1 times 2 to the x, where a is 1 and b is 2. Okay, since b is greater than 1, we see that the function is going to be increasing. But let's examine some points that are on this curve. Okay, so when x is 0, y is 2 to the 0 power, or just 1. When x is 1, y is 2 to the first, or 2. And then when x is 2, y is 2 squared, or 4. And notice every time as x increases by 1, y doubles. Okay, so you can imagine when x is 3, if we double 4, we find that y is 8. And the graph of the function would look something like this. So let's try to graph each of the following examples. Okay, the first one, we have f of x equals 3 to the x. And so we'll make just a table of values. I'm going to choose x to be -1, 0, 1, and 2. And y, if I take 3 to the negative first, that's the same thing as 1 over 3 to the first, or 1/3. 3 to the 0 is 1. 3 to the first is 3. And 3 squared is 9. Notice every time as x increases by 1, the y's are multiplied by a factor of 3. So we plot these ordered pairs. So -1, 1/3, 0, 1, the y-intercept is at 1, 1, 3, and then 2, 9. And connect the points with a nice curve. Okay, so for a moment, let's take a look at the domain and range of this function. We see that I can select any x value and plug it into the function equation to produce a corresponding y value. So even a number like -1,000, 3 to the -1,000 is a number that's just very close to 0. That's the same thing as 1 over 3 to the 1,000th power. Okay, so we can say that the domain is all real numbers, or -infinity to infinity, but the range is not all real numbers because the y values do not reach 0. And so we're going to say the range is from 0 to infinity. And one other important part of the graph is this imaginary line that the curve approaches. It happens to lie on the x-axis in this particular problem. And so this horizontal line at y equals 0 is called an asymptote. Every exponential function will have one. Now let's try to graph g of x, which is 2 times 3 to the x. Okay, so we'll make our table of values. I'll also select the same x's, -1, 0, 1, and 2. Okay, this time we see that a is 2 and b is 3. And so the y-intercept, initially I can tell that it's 2 just from the formula. And the growth factor is 3. Okay, so to determine these y-coordinates, we can first find g of -1, and that would be 2 times 3 to the -1st, or 2 times 1/3, which is 2/3. Okay, we already found the y-intercept. If we find g of 1, that's 2 times 3 to the 1st, or 6. And notice the difference between these y's is also a factor of 3. And so I can immediately find the next y value. It's just 6 times 3, so 18. Graphing these ordered pairs, we see that this graph is steeper than the last graph, but it definitely has that same curved shape, and also the same horizontal asymptote at y equals 0.